They are some of the most majestic features on our planet, towering mountains that command respect and awe. But beneath their tranquil exteriors lies one of nature's most formidable and destructive forces. A dangerous volcano isn't necessarily the biggest or the one that erupts most often. True danger is a combination of explosive power and a critical factor: proximity to people. In this video, we explore some of the world's most dangerous active volcanoes, geological giants that pose a significant threat to millions. To understand what makes a volcano dangerous, we must look beyond simple lava flows. The primary factors are the volcano's eruptive style, the types of hazards it can produce, and how many people live in its shadow. First, the eruptive style. This is largely determined by the magma's composition. Magma with low viscosity, meaning it's thin and runny, allows gases to escape easily. This typically leads to effusive eruptions, where lava flows relatively gently, like in Hawaii. While still destructive to property, these are often less deadly. The real danger comes from high-viscosity magma. It's thick, sticky, and rich in trapped gases like water vapor and sulfur dioxide. As this magma rises, the pressure drops, and the trapped gases expand violently, leading to explosive eruptions. These eruptions can blast ash, rock, and gas tens of kilometers into the atmosphere. Volcanoes that produce this magma are often stratovolcanoes, the classic steep-sided cone shape we often picture. Second, the specific hazards. It's rarely the lava that poses the greatest threat to life. Explosive eruptions create pyroclastic flows, superheated avalanches of ash, rock, and gas that can exceed 1,000 degrees Celsius and travel down the volcano slopes at hundreds of kilometers per hour. They are impossible to outrun. Another major hazard is lahars, or volcanic mud flows. The heat from an eruption can instantly melt snow and glaciers on a volcano summit, mixing with volcanic ash to create a fast-moving slurry with the consistency of wet concrete, burying everything in its path. Finally, volcanic ash can blanket entire regions, collapsing roofs, contaminating water supplies, and crippling air travel. History provides stark warnings about these dangers. Perhaps no volcano illustrates this better than Mount Vesuvius in Italy. In 79 AD, Vesuvius unleashed a cataclysmic Plinian eruption, named after Pliny the Younger, who documented it. It sent a column of ash and pumice high into the stratosphere, followed by devastating pyroclastic flows that completely buried the Roman cities of Pompeii and Herculaneum, killing thousands. Today, Vesuvius is arguably one of the most dangerous volcanoes on Earth, not because it is exceptionally active, but because more than 3 million people live in its vicinity, with 600,000 living directly in the red zone at its base. Italian authorities have extensive evacuation plans, but the logistical challenge of moving that many people with little warning is immense. Vesuvius remains a constant, looming threat over the city of Naples. Across the Atlantic in the United States stands another major threat: Mount Rainier. This massive glacier-covered stratovolcano towers over the Seattle-Tacoma metropolitan area. While an eruption would be devastating, many volcanologists believe its greatest threat is lahars. Mount Rainier is covered by more glacial ice than all other volcanoes in the Cascade Range combined. As long as Casuales in 1948 mean that this likely event is a state regretting for not only colors collision, but also significant impacts in the combination of severe fire and lethality. Even a small eruption could rapidly melt this ice, creating colossal mud flows. These lahars would not be confined to the mountain itself. They would surge down the river valleys that drain from its slopes, traveling at high speeds for dozens of kilometers. Cities like Puyallup, Sumner, and Tacoma are built on top of ancient lahar deposits, meaning they are directly in the path of future flows. The United States Geological Survey, USGS, has installed a lahar detection and warning system, but it might only provide minutes of warning for communities to evacuate to high ground. But some volcanic threats are not on a local, but a global scale. Beneath the stunning beauty of Yellowstone National Park lies a supervolcano. It's not a mountain, but a massive depression in the ground called a caldera, measuring about 55 by 72 kilometers. Yellowstone sits on a hotspot, a plume of magma rising from deep within the Earth. It has had 3 super eruptions in the last 2.1 million years. A future eruption of this magnitude is an extremely low probability event, but its consequences would be global. Such an event would eject enormous volumes of ash into the atmosphere, which could trigger a volcanic winter. The ash would block sunlight, causing global temperatures to drop and severely impacting agriculture and food supplies worldwide. Again, while the chance of this happening in our lifetime is very small, its potential impact makes Yellowstone a volcano of global significance. These examples underscore why monitoring and understanding volcanoes is a matter of life and death. Volcanology is a critical science that aims to forecast eruptions and mitigate their impact. Scientists at observatories around the world use a variety of tools to keep a constant watch. Seismometers detect small earthquakes caused by magma moving beneath the ground. Global positioning systems, GPS stations, and satellite radar can detect subtle swelling or deformation of the volcano's surface as magma chambers fill. Gas sensors measure the release of gases like sulfur dioxide, which often increases before an eruption. But monitoring is only half the battle. This data is used to create hazard maps that show which areas are most at risk from pyroclastic flows, lahars, or ashfall. This information is vital for land use planning and developing emergency response strategies. Public education and clear evacuation routes are essential to ensure that communities can act quickly and safely when a warning is issued. The 2010 eruption of Eyjafjallajökull in Iceland, while relatively small, grounded air traffic across Europe for weeks, demonstrating that even remote volcanoes can have a massive societal and economic impact. The world's most dangerous volcanoes are a powerful reminder that our planet is a dynamic and ever-changing system. They are not inherently evil, they are a natural part of Earth's geology. The danger they pose is a direct result of where we choose to live. Through continuous scientific monitoring, careful planning, and a deep respect for their power, we can learn to coexist with these sleeping giants and protect the millions of people who call their slopes home.